everyone. As you already know, I'm Eileen, and I'm honored to be your closing keynote for Euruko this year. I just want to say thank you to the organizers for throwing such a great conference and inviting me back. I haven't been to a Euruko since Rotterdam, so and it's my first time in Portugal. You all have a lovely country. I will definitely be back. I'm a senior staff software engineer at Shopify on the Ruby and Rails infrastructure team. Our goal on this team is to improve Rails and Ruby for the entire community while ensuring that Shopify has a strong foundation to support our merchants. I've been a member of the Rails core team since 2017. We're the driving force behind the Rails framework. We make decisions about the direction of the framework and the evolution of Rails, as well as collaborate with contributors and the community. A year ago, I also joined the Ruby core team, which has been an honor. Improving the language and framework we all know and love has been the highlight of my career. I've been building Rails applications for about 15 years now. I had to do the math because everybody kept asking me how long I've been writing Rails. I was like, I don't know. Turns out it was 15. So throughout my tenure, I've seen a lot of Rails applications. I've worked at companies that had less than 10 Rails devs and companies with thousands. I've worked on Rails applications that were brand new and others that have been around since the dawn of the framework. I've seen applications built by developers just learning Rails, and I've seen ones written by David himself. Throughout my career, I've spent extensive time working on two of the largest Rails applications in existence, Basecamp Classic, too low, and too far, and Shopify. While Basecamp Classic is still running in production, it only gets security updates. So this makes Shopify's core monolith the oldest continuously developed production Rails application on the planet. It was built on a version of Rails that wasn't even released to the public yet, and now it runs on Rails Edge. While the application has changed a lot in the last 20 years, it's fun to look back in history at Toby's first Shopify commit and just see how excited he was to be using Rails. Whoops. In between 37 Signals and Shopify, I worked at GitHub for 5 years and spent the first 2.5 years upgrading the main monolith from Rails 3.2 to running off Rails Edge. I think I'm the only person who has worked on all three of these early Rails applications. And one thing that stood out over the years is that eventually Rails monoliths get to a state where the framework stops bringing developers joy and happiness. As an organization grows, applications tend to become a ball of mud. The code lacks organization and structure, onboarding is difficult and painful, CI is slow, tests are flaky, its simple changes seem to involve endless amounts of friction. At this point, many companies ask themselves, what now? They feel like Rails is no longer meeting their needs from an architectural perspective. Often organizations will start grasping for microservices in order to get the experience of building a greenfield application and to move away from their monolith. Engineers will invent reasons their project doesn't belong in the main application so they can build new things. When I was at GitHub, there was a point where all anyone could talk about was microservices and how that was the silver bullet that would save us from ourselves. About 7 years ago, Shopify began exploring modularizing our core monolith. At the time, it seemed like the best of both worlds. Componentization would feel like working on a smaller application without network latency and organizational politics of microservices. It would solve all of our problems, we get to keep writing Rails. What could be better than that? But in 2022, GitHub also started modularizing their monolith as well, realizing that turning the entire monolith into all microservices wasn't a tenable goal. Although I don't really think the microservices obsession has really ended there, unfortunately. Gusto, Zendesk, Doximity, and other companies with large monoliths have also adopted this architecture. And while I hear a lot of voices pushing for this new pattern in Rails applications, it has not proven to be the silver bullet that we had hoped for. After all of these years, if we look back at the problems we were trying to solve, we'll see that they're ever present and new challenges have arisen from pursuing this architecture. The myth of the modular monolith is that it promises a greener pasture, better structure, less coupling, but what we get instead is a new set of challenges and unmet goals. On the surface, problems appear to be technical, but if we look deeper, we'll see that they're actually human and cultural problems. And you can't solve these types of problems by simply changing your architecture. Today, we'll examine the difficulties companies face as their applications scale. We'll explore why modular monoliths seem like an ideal solution and uncover the underlying causes of the issues that we're trying to address. We'll discuss how to tackle these challenges while avoiding the pitfalls of chasing false promises and silver bullets. First, let's explore the very real pain points that led companies like Shopify, GitHub, Gusto, and others to modularize their Rails applications. Many companies that are expanding, hiring, and growing will face the same challenges over time. I have categorized common problems into 3 types: architectural, operational, and organizational. Architectural issues refer to challenges that are related to the overall design and structure of a software system. They affect maintainability and scalability of your application. Architectural problems creep in over time, and as more and more features are added to an application and refactoring existing code isn't prioritized. A common architectural problem that occurs in growing applications is the lack of organization and structure. Rails is an MVC framework, so it does have some structure, but all the models go in app models, and controllers in app controllers, and views go in app views, and so on. And as the amount of code increases following Rails' default directory structure starts to become unwieldy. How do we relate things to each other? The lack of organization and structure means that developers rarely consider where new code should go, or when it's really important to refactor existing code so that it should live elsewhere. Everything just kind of ends up in the default folders, making it difficult to discern what concepts belong together. This is often what developers mean when they talk about the ball of mud, as if it's Rails' fault and not our own that the code doesn't follow a proper design. In addition to lack of organization and structure, another architectural problem with growing applications I hear about is tight coupling and lack of boundaries, and how problematic that is. It's easy to see how this happens in a Rails application. Ruby is a language where code is globally accessible, so without good judgment, code can easily become tightly coupled. Changes that seem simple unintentionally impact parts of the application in ways that are hard to predict and control. And when this happens, you either have to fix all of the callers or refactor the codebase to separate the functionality. Side effects caused by tight coupling and lack of boundaries harm developer productivity. In addition to architectural problems, applications face many operational challenges. These types of problems refer to the practical aspects of running and maintaining applications. They affect the overall happiness of your engineering organization. An example of an operational issue is flaky tests and slow CI. While any size application can have flaky tests, the larger your monolith is, the more likely flakes are to occur, and the harder it is to narrow down their cause. Flaky tests can block deploys or make CI runs take longer due to rerunning failed tests or whatever else gets in your way. A flaky build adds friction and frustration to development, and it makes all of your engineers very sad. Often, engineers working on large monoliths will complain that their CI suite takes way too long. While the amount of code certainly does contribute to longer CI runs, it's not the only cause. CI might be slower due to a test that creates too many records, queries that are ridiculously slow, or doing network calls in your tests instead of stubbing them out. There's a lot of things that contribute to a slow test suite, but they become more problematic as a monolith and organization grows faster than your problems can be addressed. In addition to slow CI, when a monolith gets to a certain size, it's common to hear complaints that it's difficult to scale deployments effectively. The larger the application, the longer it will take to check out the code and restart the servers. As an application gets more customers, you'll need more infrastructure to handle that traffic. Due to Rails being a monolith, it's just not possible to deploy to more servers for a resource-intensive part of the code base. Deploys are the whole application or nothing. Lastly, organizational problems are issues at the company structure level. They are related to how work is managed, how quickly problems get solved, and how well an engineering organization is functioning. Organizational problems can happen regardless of the size of a monolith or company. However, they're exacerbated by growth and scaling needs. So one example of an organizational problem is that it's difficult to assign and find owners in an application. At smaller companies, you might be like, everyone is responsible for this whole application, but that doesn't scale if you have thousands of engineers. When the application gets to a certain size, you need to split up that responsibility so that bugs get fixed and you know who to page during an incident. It's untenable to put thousands of engineers on an on-call rotation for code they don't understand, especially with all the technical debt that you've let build up. Another organizational issue is how long it takes to onboard new hires. The argument is that it's hard for new hires to get started shipping because they can't find their way around a monolithic code base. If that monolith was modular, they could, in theory, just focus on code that belongs to their team. Coming into a giant monolith, especially if you haven't written Rails before, can be quite daunting. It makes sense that smaller code bases are easier to reason about for new hires. So one argument that I hear often for why large monoliths are problematic is people always come up to me and they say, I can't hold the whole application in my head. When I hear this, I wonder, why are you doing that? Why are you trying to do that? Stop doing that. I have never once ever considered holding the whole Shopify application or even the Rails framework in my head, regardless of whether it's modularized or not. What I can hold in my head is different from what you can hold in your head, and what Matt's can hold in his head, and what you can hold in your head, or you. It doesn't, whether you can hold the whole application in your head or not is not a valid argument for the correct size of an application. This metric is different for everyone, so unless we can define the exact number of lines of code we deem reasonable, I don't want to hear this particular argument again. The other ones are valid, not this one. Realistically, as our companies and applications are more successful, our monoliths grow over time. It's more important that we focus on having well-designed, properly structured applications that follow Rails conventions than it is to pick an arbitrary number of lines that we can hold full context on. Having monoliths small enough to hold in your head isn't a tenable or reasonable goal. It's also silly because a monolith is still a monolith, even if it's modular. What if your team owns multiple components? The other problems we discussed, though, as I said, are very real. I've experienced them at multiple companies I've worked at, and I've heard about these problems from lots of engineers that I've talked to. In order to solve this set of problems, though, companies will reach for microservices or try to carve up the monolith. Instead, Shopify, Gusto, GitHub, and Doximity, and others reached for a modular monolith. A modular monolith is one that is organized into modules inside the original codebase by grouping domains into logical directories. The promise of a modular monolith, in theory, is that it provides the best of both worlds, the isolation and boundaries of microservices with the ease of deployment and development of a monolith. There are a lot of reasons to choose a modular monolith over microservices. One is that you get to keep saying modular monolith over and over again, like you're doing a tongue twister. With modular monolith, you get to keep using the same language. That's great, right? If you're going to move to microservices at your company, you're probably going to have to start writing Go. And while, Go is fine and all, I want to write Ruby. I don't want to write Go. So it benefits me to stick with the language that I actually like, that I want to write every day. And it benefits everyone else who loves Ruby too. In addition to that, modular monoliths mean that you don't have to build out new infrastructure. Deploys and CI work the same way as they did before, which means the overhead for migrating to this architecture is actually quite minimal, at least to start. Deployments and testing for microservices can be more complex if they're interdependent, whereas a modular monolith is deployed and tested as a single unit, unless you change that. Another advantage of a modular monolith is that it promises, or at least it wants to promise, a path towards package isolation. Isolation means creating boundaries between components and attempting to remove dependencies and coupling. In order to define and enforce boundaries between your modules, you need to use a tool like Packwork and then have that do the work then you have to do the work to remove dependency violations. If you want to modularize your Rails application and your goal is to be able to run separate CI jobs for different packages or deploy a package to its own infrastructure, isolation would be required. But unfortunately, true isolation is really, really difficult to achieve. And later on, we'll take a closer look at why it might not be a path worth actually pursuing. Currently, I am not aware of any applications that are deploying fully isolated modules of their monoliths to production, and that includes Shopify. At Shopify, we have isolated one single component that can run CI in isolation, but it doesn't contain any product functionality. It's essentially the active support of our application, so therefore it's actually not useful to deploy on its own infrastructure since it's not a high traffic component that is affecting our response times. Generally speaking, in the Rails world, modular monoliths use Rails engines to organize code and Packwork to define and enforce boundaries between their packages. Rails engines are native to the framework, and Packwork is a gem written by Shopify. Let's take a minute to see how this works in practice. So let's say we have a company called Fur and Foliage that sells both plants and pets. In a standard Rails applications, the directory structure might look like this. If you have an application with 4 concepts named dog, cat, tree, and flower, you have corresponding models in the app models directory, controllers, and app controllers, and so on. If we were to modularize with Rails engines, our application might be organized like this. Here we've grouped dog and cat into a pets engine, while tree and flower are grouped into a plants engine. We call these packages. I've purposely oversimplified this example of how modular monoliths work. At Shopify, we have top-level components, many of which have many nested packages inside. There are many talks and blog posts available that address the decision-making process and details of how to modularize a Rails application. So go watch those if you actually want to know more. This talk is meant to be a higher-level overview. We're going to go deeper on the technical implementation of a modular monolith. So when you have a modular monolith that's only modularized with Rails engines, it does not inherently reduce dependencies or create isolation because all the code is still globally accessible. So you can use Packwork to identify and enforce boundaries between plants and pets. As mentioned, we wrote this at Shopify. This talk is not an endorsement or criticism of Packwork. I'm using it for my examples because I'm not aware of any other tool that does this, is designed to do isolation in this way. Packwork allows you to define dependencies between packages and enforce those boundaries by not allowing undeclared new dependencies. With Packwork, dependencies are defined in a YAML file. Each package has its own package.yaml that contains the metadata for the package and its what it depends on. So in this example, pets depends on plants. This is considered an allowed dependency. This says it's okay for the package to rely on constants and methods in the plants package. When enforce dependencies is set to strict, it prevents adding any new dependencies to the pets package. In addition to the package YAML file, there is a to-do file which declares dependency violations that you want to work on removing. If you want your package isolated from all other code in the monolith, you need to fix all of these to-dos and remove these allowed dependencies. So at Shopify, we have a little over 40 top-level contexts defined, and most of those contain nested packages. In our core application, we have over 90 package to-do files, and there is no concerted effort to actually burn that down. We're not even tracking whether we're actively reducing dependencies because we found it's not a useful metric. Enforcing strict boundaries causes too much friction for developers. Packwork is a tool that's helpful for knowing most dependencies between packages, but it cannot tell you how to rewrite your code to have less coupling or how to refactor existing violations to create boundaries. So rather than think of Packwork as a to-do list, think of it more as data or an AST for helping you understand your dependency graph where changes might be needed, but it doesn't always create better code to actually do this isolation. Because modularization and isolation tools can't actually tell you how to write better code. It can sometimes cause new problems to crop up in your application. This isn't Packwork's fault. It's that we're attempting to isolate or remove all dependencies in a large-scale monolith, and it's very, very difficult to do that right and not end up with an undesirable worse pattern. One problem that I've seen in large monoliths trying to prevent new or existing violations is primitive obsession. An example of this is passing IDs around instead of active record objects in order to avoid calling constants between packages. Often developers will load records from the database, get IDs, and then pass them to the other package, and then load those records again because in Packwork, the IDs are not considered a violation. So as an example, we had the first top is before we get rid of our dependency violation. So we have a method cat can eat. Can cat eat this flower? If it's safe for cat, if we wrote this regular active record in a monolith, it would be the first example. But to get rid of our dependency, we have to change this so that we pass just cat ID instead of cat object, which was already loaded. So now we have to load it twice and then make this cat getter extra class public interface in between to find the cat that we already found that we passed. So that's how we got the ID. And so you end up with these performance issues because you're double querying your database, and data duplication and all this other stuff. And so you end up with a messy, that doesn't look that messy, but trust me, I've seen things. It scares me sometimes the way we have tried to get rid of dependencies between components. So if one package already loaded cat just to pass the flower, then it means the database is queried for the same data twice. When we're using these primitives, we might circumvent the dependency violation and reduce coupling, but the downside is the database performance issues that affect your customer. Database performance issues actually affect your customers more than they care about what dependency violations you have. If you prevent engineers from using Active Record the way it was designed, you end up with far worse patterns and issues in your application design and structure. One of the benefits of a modular monolith is that there's no network latency between packages, like there would be with microservices. But if you're doing so much primitive obsession and re-querying the database multiple times, all of the gains that you have from no network latency are nullified by database issues. So we have to be careful that we're putting up guardrails of how we want people to write monoliths, that we don't end up encouraging worse anti-patterns. In addition to primitive obsession, I've also observed a big problem with ownership obsession. This refers to the mindset that code within a package is solely the domain of the owning team, leading to resistance against input or oversight from others. While establishing clear boundaries between packages can promote modularity, it can also create silos that result in an us versus them mindset when the code base should be viewed as a shared responsibility. Ownership obsession often results in this selfish mindset. Teams will refuse to fix code in a package they don't own because it isn't their problem. Often, the right change to make is the harder one, but they'll avoid touching someone else's code at all costs to the detriment of code quality and simplicity. Drawing strict boundaries within an application can have a negative impact on collaboration. The idea of a package functioning like a smaller Rails application is appealing in theory. However, this leads to teams preventing others from accessing their code or enabling them to defend poor design choices. It becomes a negative consequence of modularity. This erodes collaboration and undermines our engineering culture. I've also seen a lot of package obsession with putting every new concept into its own package. Teams often, they want to create yet another package because it doesn't fit into the existing ones, or they think it doesn't. At Rails World, somebody told me they put every model in a separate package. Every single model with its own component. I was like, I don't know what's happening right now. That's definitely not, even if I believed in modular monoliths, that's definitely not the way to do it. I'm sorry if you're here. I don't remember who that was, but please, nobody do that. If you aren't careful about preventing everything from being a new package, you're going to end up with a code base that's either modeled after your org chart or worse, has completely no design at all. It's important to constantly design to scrutinize your code design, regardless of what tool you're using. Because as humans, we love to categorize things. We want them to fit neatly into little boxes. But going so far as to make everything its own category leads to a fractured code base where functionality isn't grouped together. It's important. It's almost like you create microservices inside your monolith if you're going to put everything in its own package. It's like, what's the NPM one where like it was like just adds a trailing comma or something, I don't know, or like adds a new line. I don't remember which one it was, but there was one that was like, it's so small, all it did is this one tiny thing. You're like, who needs that? It should be in the standard library. Anyway, so in a modular monolith that enforces boundaries, another issue is code duplication. No one wants to violate dependency constraints or create new ones, so it's common to see code copied from one package to another. And when this happens, code becomes it becomes difficult to maintain cohesion because one version of the code is now living somewhere else, and now everybody's just changing it. And so you have two things that do kind of the same thing, but like now do actually very different things. You end up with subtle bugs, and sometimes it actually makes upgrading Rails a lot harder if one of them has deviated from what is expected. Your code base becomes really bloated over time, and if you're concerned with application design and structure, duplicating code is a massive design smell. Copying code just to avoid a dependency violation should be treated as an opportunity to rethink what that code is being used for and why. If it's truly shared, it should be moved to a package that's designed to have shared code or potentially turned into a gem. Copying existing code from one package to another here is not the correct answer. Another challenge that you get with modularizing, isolating Rails applications is introducing circular dependencies. Untangling dependencies in a large-scale Rails application is incredibly daunting, and it's really difficult to prevent new circular dependencies from being added. If the pets package depends on plants and plants depends on pets, how are you going to isolate them from each other? They have too much shared understanding. To avoid this circular dependency, many developers will use primitives or REST APIs or GraphQL calls, which tend to introduce performance regressions along the way. To correctly isolate these packages, often major refactoring needs to be done to pull out shared code and untangle the mess. But no one ever wants to end up doing a refactoring that's desperately needed. Having explored the problems caused by modularization and isolation, let's revisit the original problem to see how modular monoliths architecture falls short in addressing them. So the problems we talked about earlier are the ones that many companies cite when reaching for modularization. And yet, if we look at the state of applications using this architecture today, we'll see that all of these problems we set out to solve are not solved. And this is because they're human and cultural problems, not technical ones. At the root, no amount of moving around code into other directories or migrating to a different architecture is going to fix these problems. Architectural problems are human and cultural problems because our tools can't tell us how to refactor code and have better organization and design. They can only tell us where there is a potential problem. So can modularization and isolation automatically improve code structure and organization of an application? No. When an application is modularized, code no longer lives at the top-level directory, but that doesn't mean the packages themselves are well organized and properly structured. We still need to put a lot of effort into figure out where things should live and prevent packages from becoming disorganized. Humans are great at categorizing things, but we're not always great at choosing the right category. Simply looking at the name of a feature doesn't tell us who uses it, what it does, what its dependency should be, or where it should live. While modularization and isolation are a way to improve organization and structure, it requires an understanding of how to actually design software before you can do that. Let's look at the next one. Can a modular monolith make our code automatically less tightly coupled? No. Because modularization and isolation only can help you identify dependencies. It doesn't actually reduce coupling or introduce boundaries unless you refactor that existing code. Adding dependency violations to a to-do list and setting up allowed dependencies doesn't improve the design of your code. It just tells you where there's a problem and a possible undesirable design. You still have to understand how to rewrite and redesign existing code while not deviating too far from the Rails way. This is a human problem because it requires educating teams on how to design software for Rails while avoiding implementing worse patterns that cause primitive accession. Operational problems are human problems because they need to be fixed at the source, and they are often caused by technical debt rather than the architecture being used. So, will modularizing your monolith speed up your CI builds and make your tests less flaky? No. There is nothing about modularization or isolation that inherently improves CI. Flaky tests aren't necessarily caused by having a monolith. They could be caused by network calls, creating records and tearing them down before you actually use them, race conditions, resource contention, leaked state between tests within the same component. Or the other day I found tests that were setting the global read-only on the whole MySQL server to true. So any test that ran at the same time as those would fail with a read-only error. That had nothing to do with the monolith. That had everything to do with global state. Because flaky tests have many causes that go way beyond application architecture, modularizing and isolating a Rails application won't fix anything by default. The same goes for speeding up CI. If the reason that CI is slow is because you have slow queries or a really large test suite, it's not going to be made faster by putting code into a different directory. Will modularization allow us to deploy in isolation and therefore make our deploys more scalable? Not yet. Not entirely no, but not yet. The existing modularized monoliths that I know about in the Rails ecosystem are all still deployed as a single unit, as if they were a traditional Rails monolith. As far as I'm aware, no one has isolated a part of their monolith to be deployed separately while remaining in the same code base. It is a goal of ours. It's a lot harder than it sounds. This sounds like an architecture problem, but it's a human problem because untangling dependencies in order to scale deployments in isolation requires redesigning major parts of the application. Organizational problems are human problems. I mean, this is probably the most obvious human problems, but they're deeply rooted in an organization's leadership and are directly related to what we define as company culture. When you modularize your monolith, can finding and assigning new owners be easier? Somewhat. It is theoretically easier to assign owners to a folder instead of individual files. However, just because you know who owns something does not mean it's easier to get them to do the work. If exceptions and deprecations aren't prioritized or incentivized, the owning team will almost always choose to ship features over doing maintenance work. Additionally, reorgs, renaming teams, pivoting parts of your product can all result in sections of the code base becoming essentially unowned. As your organization grows, it's more important. It becomes more important to be able to define and have ownership of code. But changing your architecture doesn't actually fix that by default. All it does is contain the code that needs an owner. But ownership is a cultural problem, not an architectural one. In a modular monolith, can onboarding new hires be easier? So this is really hard to measure, but I'd actually argue the answer is no. Like, it feels like it's easier, but it's not actually easier. Because a modularized monolith is still a Rails monolith where CI runs all the tests and is deployed as a single unit. A change in one package could still affect another because many packages remain tightly coupled and we haven't burned down our to-do list. I don't think it's accurate to say that modularization allows you to consider only the domains you own. In addition, a modularized monolith deviates from Rails conventions, and therefore onboarding someone to your application requires teaching them not only Rails, but how to use these tools that change how code is written in your application. The tools we use to maintain structure and style create friction in development, and they may not actually put new hires in a position to ship faster. Setting boundaries in an application doesn't teach someone how to write idiomatic Rails code. It just tells them when they maybe did something bad. Looking back at these problems that we set out to solve and how they're still ever present, and then all the new problems that we have, you might think that I'm totally against modularization. But where code lives is not actually my biggest concern. What concerns me is that isolation is actually very hard, especially in a language and application that's designed to be global. It's also hard because the applications that we're modularizing are 15 to 20 years old, made up of millions of lines of code and worked on by thousands of engineers with varying experience. The reason these problems aren't solved isn't because we didn't try hard enough or because modularization is bad or because we don't have the right tools. The reason we haven't solved our architectural, operational, and organizational issues is because you cannot solve human problems with modularity. These problems that we're trying to solve are cultural. They are indicative of dysfunctional engineering organizations. Because the problems are not due to technology architecture we choose, we would have these problems if we'd chosen to stay with a monolith or if we went to microservices, because the problem isn't our architecture. No amount of architecture can save you from an organizational structure that doesn't prioritize code quality, fixing technical debt, and allowing engineers to pivot when a path is clearly not working. Organizations promote and incentivize silver bullets instead of rewarding maintenance and foundational work. In order to address the problems I presented today, we need to understand their causes. How does an application get to a point where it feels like a ball of mud? If you've worked at a startup or on a greenfield application, you know it doesn't start out this way. If Rails created a so-called ball of mud from day one, nobody would be using it. The truth is that an application goes to shit slowly over time, commit by commit, until development and productivity have come to a screeching halt. There is no single cause of these problems, but we often fail to see them until it's too late. When there's no time or ability to fix the problems we see the correct way, we blame our tools, we blame Rails, and we blame each other. Pressure to ship is one of the many reasons that applications turn into a ball of mud. It's much easier to keep the application loosely coupled with good structural organization when there are only a few developers adding features and no rush to ship. But when you get funding and stakeholders want to see a return on their investment, or you go viral and get more customers than you can handle, the only way to keep going is to ship, ship, ship. Any maintenance work or technical debt incurred is ignored because fixing that isn't the priority. It's not even on leadership's radar. Over time, code becomes tightly coupled because bolting onto existing functionality is easier than pausing to properly refactor what's already too entangled. As the pressure to ship mounts, technical debt grows. This is both incurred in the form of ignoring maintenance needs like Rails upgrades and gem upgrades, as well as bolting on new functionality onto existing code without doing a refactoring to make sure it has good design. When the priority is shipping over quality and fixing things the right way, technical debt has a way of silently growing without being noticed. Before you know it, you're years behind on your Rails and Ruby upgrades, there's monkey patches everywhere, and seeming innocuous changes take weeks to implement and ship. Fixing exceptions feels near impossible. Now there's hundreds of thousands a day. With all that noise, what's one more exception? No one wants to take or can take responsibility for maintenance when the only way to get promoted is to ship features. The pressure to ship and the mounting technical debt increases the pressure to hire. You need more developers to ship more code, and the ones you have aren't working fast enough. Because the company is prioritizing growth over code quality, new hires never get onboarded properly. No one teaches them Rails or how an application should be designed. They're thrown into the deep end with no support. They feel overwhelmed and unproductive, and so they blame the framework. New hires are complaining that Ruby is slow and bad and we should rewrite another more popular language like Go. All they see is technical debt, no structure, tight coupling, and slow CI. Something has to be done. Shipping too fast and increased hiring are both symptoms of a larger problem, that growing organizations have growing problems, and those problems are caused by misaligned incentives. As organizations get larger, they need to add more and more layers to leadership to make sure everyone's doing their job properly. OKRs and KPIs become the metric for whether things are going well, and the obvious culture problems that led us to a state where our application feels fragile and fractured continue to be ignored. In order to meet their OKRs and KPIs, managers and VPs need to know who to assign work to and who's accountable for outages. Their thinking is, if we just knew who was in charge of this code, we can measure who is and isn't doing their job. While you need to know who owns code in a large application, it's often taken way too far. Rather than working together and collaborating as an organization, misaligned incentives breed a blame-based culture that results in siloed teams who want to protect their code from the rest of engineers at all costs. The desire to modularize and isolate comes from wanting to feel like you don't have to think about the rest of the code base. However, it quickly turns into the code is mine to protect mentality. I watched this happen at GitHub while I was there. As the application and organization grew, it felt like it became more important to figure out who to blame than it did to work together on fixing technical debt. And this blame-based culture leads teams to want to protect their code and database queries from the rest of the organization so they can prove they weren't the cause of the outage. Within the org, keeping teams away from your code becomes far more important than collaboration because collaboration means it's not clear who to blame. This culture erodes teamwork and empathy. The problems that we looked at today aren't solved by organization, structure, and isolation because they aren't problems caused by technology or lack thereof. They're human problems caused by a culture within an organization, and there is no silver bullet technology that will fix that. It takes good leaders and a concerted effort to address the underlying challenges and allow applications to turn into a ball of mud over time. Not all hope is completely lost, though. Just because we can't solve these problems with architecture changes doesn't mean they aren't fixable or even avoidable. It's not evident that your application turns into a ball of mud and your only recourse is to spend years trying to change your architecture and moving your code into little different directories, hoping that one day it'll feel right. In order to address the human problems we're facing, we need to improve our developer education. We cannot keep hiring developers and failing to train them on how to write Rails the Rails way. Engineering onboarding at most companies is barely a week, if at all. That's not enough time for a new hire that is proficient in another language to really learn Rails. If we don't train new hires why we use Rails, how to write Rails, how to organize code, how to write tests, how to use features of the framework, how to avoid sharp knives, and how to follow Rails conventions, we're doing ourselves and them a disservice. We cannot expect dependency violations to teach anyone how to design software for Rails applications. Companies who are hiring developers to write Rails need to do more education. Part of this education also comes in the form of making sure every team has at least one person that knows Rails well. At Shopify, we pull teams that have nobody who knows Rails or Ruby on them. And it ends up with code that doesn't make any sense that we're constantly chasing after and trying to fix. If you don't train your engineers how to write well-designed idiomatic Ruby code at scale, you're going to end up with a mess. This isn't their fault, it's ours, because we failed to train them. In addition to education, we have to indoctrinate newcomers to actually say, like, this is why Rails is so great. This is different from education because it goes beyond the technical basics and is a way to we need to evangelize developers using Rails. When I first started writing Rails, everybody was giving talks about how great Rails was and why it worked the way it did, and like all of the interesting things, like to explain that it's not just like sometimes new people will come to Rails and they'll be like, oh, it's backwards. Like, why does it do it this way? Because like their language doesn't do that. And I said, well, because it's on purpose. Like, we want to test with the database. We want to organize our code this way. We want meta programming in Rails that gives us our associations for free. But if we don't tell anyone like why that's great, they're just going to look at it and be like, this is weird. I don't know what this is. When your only experience with Rails is an application that is deviated from the Rails conventions and is littered with technical debt, you're not going to be able to see the beauty of the framework. You're going to be like, what is this? What is this? What am I looking at? Without indoctrination, without getting our coworkers to fall in love with Rails, all they see is just another tool, another language. But we know Rails is more than just a Ruby framework, and I want others to feel the same joy I do when writing Rails applications. Leaders also need to prioritize quality. It's easy to fall into the trap that tells us that we have to ship more and faster, but waiting until shipping is painful to improve quality isn't good for the application, team morale, or our customers. When we ignore technical debt for a long time, it has a tendency to build up to the point where everything feels impossible. I've seen so many organizations wait until it's too late, and when that happens, we start searching for silver bullets. We invest years into a path that's not going to fix any of our problems because it's easier than addressing the real problem. That we have an engineering culture that values shipping over quality, features over bug fixes, magic cure-all solutions over fixing the problems at their source. Part of the quality issues come from incentives that value shipping features or silver bullets over targeted methodical improvements. If improving performance, cleaning up technical debt, or upgrading your Rails application isn't rewarded the same as shipping features, why would anyone in your engineering organization prioritize invisible work? It's up to leaders to highlight that work and reward it with promotions and raises. We can't expect any improvement in code quality if refactoring isn't rewarded. Leaders need to both highlight and reward good work, especially when it's not visible. I've been writing Rails applications for 15 years, and I have seen a lot of different applications at varying stages in their evolution. I've spent a significant amount of time in the code bases of some of the very first Rails applications ever to be built. And what I've noticed is as engineering organizations scale and Rails applications grow, eventually they get to a state where the framework stops bringing developers joy and happiness. We find ourselves missing the productivity we had when we first started building our product. As development slows and joy is replaced with friction and frustration, we look for someone or something to blame. When I hear developers talk about how Rails applications turn into a ball of mud, they make it sound like it's inevitable. It's very common for an application that's millions of lines of code and worked on by thousands of engineers to feel like a big mess. Let's say something like, Rails doesn't provide patterns or tooling for managing the complexity of a monolith. But I don't think the challenges that we looked at today are the responsibility of the Rails framework to solve. The truth is the ball of mud is actually caused by an engineering culture that incentivizes shipping over code quality, hiring fast over education, and silver bullets over rewarding those working on technical debt. Why should Rails provide tooling for modularization when complexity, lack of structure, and friction-filled development environments aren't caused by the framework itself? Often it seems like when we reach for modularization, we're trying to engineer ourselves out of a large organization. We keep trying to find ways to make a 20-year-old monolith feel like a greenfield application, but it can't because it's not. It makes sense that as developers, we want to reach for technology solution for our problems because that's where we have control. But Rails can't engineer ourselves out of these problems, and neither can modularization or engines or Packwork or microservices. This isn't because modularization or isolation is bad. It's because we're trying to solve human and cultural problems by changing our architecture. At Shopify, we've been trying to engineer ourselves out of these problems for 7 years. Gusto, GitHub, Doximity are trying that as well, and the truth is this is uncharted territory. We're still trying to figure out how to make working on a monolith of this size bring joy to developers. If we look at the current state of our applications, we'll see that many problems we set out to fix are still ever present, and we have new issues that have cropped up. We want to blame our tools, our engineers, our framework, but ultimately blame's not going to help. We need to shift our engineering culture to value what is really important in order to solve our architectural, organizational, and operational issues. Leaders in our companies and in our community need to do more. Engineering culture comes from the top. We have to start educating new hires, not just on how to use Rails, but how to design software and what's important about the Rails philosophy as well. We need to prioritize fixing technical debt and invest in code quality over rewarding those who ship features. Features are great, but we need to reward everybody. We need to start talking about why we love Rails and indoctrinate newcomers so they keep writing Rails and they fall in love with it the way we did. We need more collaboration in our engineering organizations rather than focusing on blame-based development. We need to be curious and discerning. Don't fall for the thinking that there's a magic cure-all solution to those problems because there isn't. The myth of the modular monolith is that architecture cannot fix human and culture problems, but fixing human and culture problems can improve our architectural, operational, and organizational challenges. And while AI is trying to eat our jobs and livelihoods, these human problems are only going to become more obvious and more important to solve. Refocusing on education, indoctrination, and collaboration will ultimately make us more successful at solving these hard problems. Let's invest in an engineering culture, embrace our monoliths, and rediscover the joy in programming RHELs at a large scale. Thank you.